Hello friends, welcome to my physics class. Today we will discuss the apparent weight of a man in a lift or an elevator. So before discussing this, if we see a lift, we must have stand on this lift. You can see this. So the lift, according to physics point of view, it can move upward, downward, or it stays at the rest. So what we will discuss the various conditions of it. Before that, if you can see a person, this is a person who is standing on a ground. He must have some kind of weight. That weight is m into g, that is mass into gravitation. So some kind of reaction r is also there to counter it, so that he can be steady in a particular place. So suppose a person of mass m is standing on a weighing machine. This is a weighing machine placed in a elevator or a lift. The actual weight of a person is mg. So this is the actual weight of a person. So this acts as a weighing machine which offers a reaction r. So I have already discussed it provide a reaction r by reading the weight of the machine. This reaction exerted by the surface of contact on a person is apparent weight of the person. So we will discuss the first case when the lift is at rest. When the lift is at rest, that means acceleration is equal to 0. So what is the net force? Net force is also 0. So R equal to mg, because R is countering the weight. R minus mg is equal to 0. So R is equal to mg when the lift is at rest. Second case, when the elevator is moving uniformly in upward direction or downward direction, still the acceleration a is equal to 0. So when we put the reaction, the same thing we got as we got in the rest. So what we concluded here, that when the elevator is rest, the acceleration is 0, net force is 0. And also in case of moving uniformly in upward and downward direction, moving uniformly, in case of moving uniformly, then also R is equal to mg. This is the called as reaction, and this is the weight of a person standing over the weighing scale. So next thing, when the elevator is accelerated upward. So now here the condition changes. Suppose a uniform upward accelerator of a person in the lift is a. So this a is with the acceleration. So net upward force equal to F equal to mass into acceleration. So F equal to R, that is reaction, minus its weight. Remember, when the acceleration is upward, then R minus reaction minus mg. This we will use equal to the net force. We will equate this. So R1 equal to mg plus F. So what we observed here, we know that what is F here? F is equal to mass into acceleration. So we add here mg plus ma. So what reaction we get? R equal to mg g plus a. We have taken m common. So here the R1, the reaction is greater than the weight, that is mg. So the what we have concluded from here, that the apparent weight of a person becomes more actual weight when elevator is accelerating upward. For example, you are standing here and accelerator is going upward direction. What happened now? Your weight become more. Why? Because of R equal to mg plus a. So because of this equation, our weight get added, and condition is that R1 must be greater than mg. So our weight is get added up. So remember this case, our weight increases as the lift moves in upward direction. Next case, when the elevator is accelerating downward. Now it's moving downward. Now force equal to same mass into acceleration. So F force equal to mg minus R2. In previous case, when the lift is going upward, what we have written, that F equal to R1 minus mg. But now here the weight becomes more than the reaction, because lift is going in the downward direction. So we will equate R2 equal to mg minus F, net force. what is F is mass into acceleration. So m equal to g minus a. Here the mg mass is greater than while the lift is going downward. So what we have observed from here, that apparent weight of person becomes less. Here the apparent weight of person then what happened, then the weight of person becomes more than the actual weight. For example, your weight is 50 kg, so your weight is added up, more weight, it shows your more weight. But when the lift is going downward, then your weight becomes less. Why? Because of this equation, F equal to R1 minus mg. So from the reaction you are minusing the weight. Next case, in a free fall, the acceleration equal to gravity, then R2 is equal to 0. So if we are standing in a lift, here there is no reaction, only there is a weight of person is there, so you became free fall. So lift is moving, you are also moving, but you are free falling in that direction. So the apparent weight of person becomes 0, your weight becomes 0, and the person becomes weightless at a free fall. So you can jump here, you will feel no weight. Same thing happened when the astronauts reach by using the rocket. So when they are inside the rocket, they can't feel anything because their weight is absolute 0. So in next case, when the downward acceleration is greater than g, so that means the acceleration is greater than the gravitation force, then R is equal to mg minus a, then R2 becomes negative. Thank you very much.